All right, just a little bit of experimenting with the distribution amplifier, the HP 5087A. This particular model, as you said, has a distribution of one 10 megahertz input and then 12 10 meg outputs. This is the power supply, generates 18 volts. And then in here you have three input amplifiers. So essentially whatever your signal source, in this case the GPS DO, which produces about 6 volts peak to peak, or just over 2.1 volts RMS. Put that into the input, and then you can control the gain so that you can kind of buffer that signal to distribute it across the amplifiers so there's no distortion. And then if you tweak the gains, individual gains of all the amplifiers, you can then obviously get a signal coming out, which is a copy of the one you're putting in, but of the right voltage levels for the machinery that you wish to drive. So this is using output 1, output 2, and this is a sample of output 3, and you can see it's about 2.58 volts RMS. Now this is being timed with the 10 megahertz external reference, and it's showing 49.999857 times 10 to the power of 6 from this generator, which is nominally supposed to be producing 50 megahertz. So using its internal clock, what it thinks is 50 megahertz is actually, according to GPS distributed amplified timing signature, is actually running a bit slow. So let's take a look at using the external clock here. And if we go to reference clock, it's using internal right now. As soon as I use the external source, which is coming from the distribution amplifier, this will catch up and you'll see 50 megahertz, because this is accurate and this is still inaccurate with the internal clock. 3, 2, 1. And there we go. So now this is generating 50 megahertz according to GPS delivered timing, and the GPS enabled counter totally shows the answer. Cool. So I hope to have a bit more use of the reference standard throughout my lab equipment and other items as and when I acquire them, with all those outputs.